Assistant Professor at LJ Institute of Engineering and Technology. Today in multiple integrals, I will teach you a new topic, that is area by double integration. So let's start. Now first of all, we will see how to find out the area in Cartesian coordinates. The area A bounded by the curves y equals to f1x and y equals to f2x intersecting at the points P A comma B and Q C comma D is A equals to integration from x equals to A to x equals to C, integration from y equals to f1x to y equals to f2x dy dx. With the help of this formula, we can find out the area bounded by these two curves, y equals to f1x and y equals to f2x. If the equation of the curves are represented as x equals to g1y and x equals to g2y, then A area, that is equals to integration from y equals to b to y equals to d. Now in this case we have to take these lines from y equals to b to y equals to d, whereas in this case we have to take lines x equals to a to x equals to c. So area in this case, that is equals to integration from y equals to b to y equals to d, integration from x equals to g1y to x equals to g2y dx dy. So with the help of this formula, we will be in a position to find out the area bounded between two curves. One is x equals to g1y and x equals to g2 of y, where the intersection points of these two curves is P A comma B and Q C comma D. Now we will see how to find out the area in polar coordinates. The area A bounded by the curves r equals to f1 theta, r equals to f2 theta, and the lines theta equals to theta 1 and theta equals to theta 2 is A, that is equals to integration from theta equals to theta 1 to theta equals to theta 2, integration from r equals to f1 theta to r equals to f2 theta, r dr d theta. So with the help of this formula, we can find out the area bounded by these two curves, right? And the lines theta equals to theta 1 and theta equals to theta 2. Now we will see example related to this topic. Find the area enclosed by the curves y equals to x square and y equals to x. Y equals to x square, that is the equation of the parabola, and y equals to x, that is the equation of the line. So here is the solution. The points of intersection of the parabola y equals to x square and the line y equals to x are obtained as the parabola y equals to x square is given to us, and we have given the equation of line, that is y equals to x. So just replacing y by x, so we have x equals to x square because y equals to x. Therefore x square minus x equals to 0. Now taking x common, so into bracket we have x minus 1 and that is equals to 0. Now equating x to 0 and x minus 1 to 0, we have value of x, that is equals to 0 and x equals to 1. So these are the values of x. Now if x equals to 0, then definitely y equals to 0 because we have y equals to x. If you will replace x by 0 over here, you will get y equals to 0. And if x equals to 1, then definitely y equals to 1 because we have y equals to x. And if you will replace x by 1 over here, so we have y equals to 1. So the intersection points are 0, 0 and 1, 1. Now this is the diagram in xy plane. This is the graph of line y equals to x passing through origin, and this is a standard curve y equals to x square, and this is called parabola, and we have to find out this area which is bounded by the line y equals to x and the parabola, y equals to x square, and the point of intersections of line y equals to x and the parabola y equals to x square are, one is this point, that is 0, 0, and the other is this point, that is 1, 1. Now from this graph we have to evaluate the limits of x and limits of y. So as you can see that this graph is bounded between these 2 points. One is 0, 0 and other is 1, 1. So definitely the limit of x will be from x equals to 0 to x equals to 1. And the limit of y will be, for limit of y you have to draw this vertical strip, and at this point A you will find y, and that is equals to x square, and at this point B you will find the other curve, that is in this case the line y equals to x. So the limit of y will be from x square to x. Hence the limit of x is from 0 to 1, and the limit of y is from x square to x. The points of intersection are O 0, 0 and P 1, 1. I have already explained you, right, how to find out the limits. So we will see once again. Draw a vertical strip AB which starts from the parabola y equals to x square and terminates on the line y equals to x. So limits of y, that is y equals to x square to y equals to x, and limits of x, that is x is 0 to x equals to 1. Therefore the given area A, that is equals to integration from 0 to 1, integration from x square to x dy dx. Now we will solve this double integration. So first of all we will integrate 1 with respect to y. So integration from 0 to 1 will be as it is, and integration of 1 with respect to y, that is y, and the limit is from x square to x, and this dx will be as it is. Now this is equals to integration from 0 to 1. Now for upper limit x, replacing y by x, so we have x. Then after minus sign, replacing y by x square, so that is x square, and this dx will be as it is. Now we will integrate x minus x square with respect to x. Integration of x raised to 1 is x square by 2. Then after minus sign, integration of x square is x cube by 3, and the limit is from 0 to 1. Now for upper limit 1, the result is 1 square by 2, that is 1 by 2. Then after minus x cube by 3, it will be 1 by 3. And for lower limit 0, both these two terms will become 0. So no need to write down 0. Now we will simplify this result. So this will become 3 minus 2 upon 6. So the result is 1 upon 6. So this is the answer, that is 1 upon 6. Now this is the second example related to this topic. Find the area enclosed by the curve r equals to 2 and r equals to 4 in the first quadrant. So here is the solution. The region of integration is the interior of the circle between r equals to 2 to r equals to 4. And r equals to 2, that is nothing but the equation of a circle having center 0, 0 and radius equals to 2. Because r is nothing but square root of x square plus y square. If you will replace r by square root of x square plus y square over here, and then after if you will square both sides, you will get x square plus y square, that is equals to 2 square. And if you will compare that equation with x minus h the whole square plus y minus k the whole square equals to r square, where hk is the center. So in this case, center will be 0, 0 and radius will be 2. Now similarly r equals to 4, that is again the equation of a circle having center 0, 0 and radius equals to 4. Draw the elementary radius vector OAB from the origin which enters in the region from the circle r equals to 2 and leaves at the circle r equals to 4. I will make you understand this point with the help of diagram, because from the diagram we have to evaluate the limit of theta and limit of r, and this is written for the limit of r, and limit of r is from 2 to 4. So limits of r, that is r is 2 to r equals to 4, and in the first quadrant limits of theta, that will vary from 0 to pi by 2. So limits of theta, that is theta equals to 0 to theta equals to pi by 2. Now this is a diagram. Now you can see that this is a circle having center 0, 0 and radius equals to 2, and this is a circle having center 0, 0 and radius equals to 4, and the region or the area bounded by these two circles in the first quadrant, that is this one, and in this first quadrant you can see that theta will vary from 0 to pi by 2, and from this elementary strip OAB you can see that at this point A we have r equals to 2, and at this point B we have r equals to 4. So definitely r will vary from 2 to 4. So from the diagram it is clear that theta will vary from 0 to pi by 2 and r will vary from 2 to 4. So the required area A, that is equals to integration from 0 to pi by 2, integration from 2 to 4, r dr d theta. Now we will integrate r with respect to r, and this is equals to integration from 0 to pi by 2. Now integration from 2 to 4 r dr d theta, because here we are integrating with respect to r first, and this is equals to integration from 0 to pi by 2. Now integration of r is to 1, that is r square by 2, and the limit is from 2 to 4 d theta, and this is equals to integration from 0 to pi by 2, replacing r by 4, so it is 4 square by 2, 4 square is 16, 16 by 2 is 8, then after minus sign, for lower limit 2, 2 square is 4, 4 by 2 is 2, and this d theta will be as it is. Now 8 minus 2, that is 6, and integration of 1 with respect to theta, that is theta, and the limit is from 0 to pi by 2. Now this is equals to 6, replacing theta by pi by 2, and then after theta by 0, so it is pi by 2 minus 0, and that is pi by 2. Now multiplying pi by 2 by 6, so the result is 3 pi. So in today's lecture we have seen how to find out the area in the Cartesian coordinates as well as in the polar coordinates, and we have seen two examples related to this topic. Thank you for watching this video. I will see you in the next lecture.